G'day folks. For this afternoon's little equipment autopsy, we have a Ford EBII Falcon dash cluster. This is the basic model, no tachometer. As it says there, GL model or taxi model. This came out of a straight bare bones package GL. All manual controls, no electronic climate control, standard stock steel wheels, grey bumpers, that sort of thing. You know, bare bones Ford Falcon. Approximately 1995 model, 94, 95. And we're going to tear it apart and have a look. It's very similar to the one in my old Fairmont, just without the tachometer, but I'll actually pull the speedometer apart and show you how it works. I'm not sure if these are electronic or not. Well, actually, of course it's electronic because there's no cable input, but we'll also have a look at that, which is a mechanical speedometer. That's out of a Toyota tray truck, like a troopy. I think it's out of an old troop carrier Toyota 78 series or 75 series, something like that. Yeah, it's an EBII base model, Monday 4th of the 7th 1994. There you go. Certification passed by VDO. It's all on there. And yeah, it's electronic. There's no cable nut or anything on the back like that one. So we'll have a look at an electronic one, and we'll also have a look at a analog one. The analog ones are cool. Electronics, not so much. Also has a lot of these spare bulb holders, which are handy. Little festoon bulb hole, not festoon, bayonet bulb holders. No, sorry, what are they? Yeah, you know what I mean. Not really festoon bulbs because they're the double-ended ones. Shit, I can't remember the name. Yeah, it'll come to me one day. Okay, I've got the front cover off. Those are called wedge bulbs, by the way. For some reason I was thinking spade, but they're sort of like a spade terminal, but they call them wedge bulbs. Looks like half of them blown, but at least I've got some good holders and a few good bulbs. Front cover comes off with a lot of Torx screws, very long ones through the bottom edge and some very short ones across the top. I did a video on rebuilding the tachometer on these a while ago. I had to do it for roadworthy, and you get the gears online. I think it's like speedogears.com or something like that, or something on Australia. I have done a full video on tearing one of these down on the Fairmont, the one with the tacho and the speedo, and they're really easy to replace the gears on. So if you want more details on that one, I might see if I can find the video and put a link in the description. This one is just going to be a pure teardown. So front cover, you got some nice big light pipes. Obviously backlighting bulbs down there, and that helps transfer light to the polycarbonate front. Because, well, light pipes make things easy. You don't have to put lamps up here, you just have lamps in the back, and the polycarbonate, or acrylic, I think it's actually acrylic, transfers that light very well. So, yeah. Go in the trash. Now, pop these off. Normally you do it a bit more, definitely do it more delicately, but these might even been come off once before and been glued on. Yeah, there is a special tool, a little fork you can make up to pop them off. I'll find something. Not that I'm going to put it back together again, it's just good practice for later projects. That's our little silk screened warning indicator, very simple. Just a piece of printed acrylic or something like that. And our bulb holders, more light tubes essentially. There's an LED in there. Yep. I think that would be smart lock. Yes, that's from the alarm system, security system. That's tacho or Odo reset. This one doesn't work either. It's also got stripped gears. It's one of the reasons why I don't feel so bad about stripping this thing down. Not that I know anyone who can use one. It's also got buggered gears. The little plastic drive gears from the synchronous motor just die. They just fail. I think it's a synchronous or pulse, probably a pulse-driven motor. It's driven off tail shaft revolutions on the back of the transmission. There's a little sender and it just sends pulses to the unit to read A, speed, and B, distance travelled. So yeah, it'll be all pulse-driven. Okay, so after somewhat delicately trying to remove the hands and failing, I've removed the plastic covers. Looks very well printed. I'm guessing they print this stuff on. It's not raised in any way, so it'll all be deposited with a printer by the looks of it. Like a test pattern or something down in the corner there. So that is temperature. That would be light piping by the looks of it, because you've got a lamp down there. Yeah, that's all light piping for the back of this temperature readout, because it's all transparent. Yeah, so these are all light pipes. And that is the temp gauge, which is driven by a thermistor. As the thermistor on the engine block heats up, it allows more voltage to flow through to the gauge, and the gauge reads higher. If I glue the little hand back on it, it's actually going to be usable again. Not that I need one. I'm just going to take it out and show you how it works, but yeah, a good way to test the old analog ones is to actually unplug the thermistor and put the lug straight to the block. And shorting it to the block, well, it should peg on maximum temperature if the gauge is alright. If it doesn't, well, generally means the gauge itself is faulty, or there's a break in the circuit to the gauge. So yeah, it works on the ground side of it. The thermistor's grounding out, obviously because it's screwed into the block with a single wire, and yeah, the hotter it gets, the more voltage it allows through. If it shorts out, obviously the gauge goes off the scale, but during normal operation it might only be seeing a few volts, but it'll bring the needle up to the desired point. And it's just working against a spring. It's actually spring loaded. No, it's not. It is. Yeah, it's spring loaded. Only slightly. There's a calibrated spring in there. Speedometer. Again, take the light pipe out. Looks like it's wouldn't be a synchronous motor, it'll be a pulse driven kind of thing. So it's not AC. AC synchronous motors, this is DC. So it's all pulse driven. And inside there, if you take that motor and PCB assembly off, there are a series of plastic reduction gears, and one of them strips. It just becomes brittle and old with age, and it dies. And yeah, you repair it by removing that and replacing it, but I'll pull that assembly out. And fuel gauge, same sort of deal. The fuel gauge, or the fuel level sender, is just a linear potentiometer. Just a flat carbon trace on a swing arm with a float on it. It's like a float in a toilet cistern. The level goes too low, it triggers the valve. In this case, if the level goes low, the voltage to this would probably increase. Of course, it's working in millivolts because the potentiometer is in a fuel tank. It'll be a lot more sensitive and much lower voltage than, say, the temperature gauge, but should be working on the same principle, at least as far as I know. Don't hold me to it. I'm not an expert on car instruments. They are left and right indicator, and we've got so that auxiliary lighting and high beam. Obviously blue, yeah, blue's high beam. That is just lighting or something. Red. Oh, it could be a lamp out warning. Yeah, being bright red, it probably indicates that you've got a stop lamp or something out. There's a break in the lighting circuit. So these all unscrew from the back, or yeah, there's nuts and bolts. Let's remove them and have a closer look. But as I said, they're very basic gauges, really. There's nothing to it. This one's the most complicated because it's the fuel sender, and it's working in very low voltage and current ranges for safety reasons. The temperature sender's the really simple one, and the speedometer and tachometer unit, well, we'll have a closer look at that one on the table. Okay, so I've got most of it out. And the little sender units actually plug in. I broke up the board thinking they were hardwired, but they're actually just mounted on pins with a single nut on the back. So an instrument rebuilder would just buy a whole new one of these and just plug it in when it's needed. It's pretty easy, pretty serviceable. But yeah, it's basically there's a little rotor in there that only does maybe 1/3 of a turn, and a couple of magnetic coils. Same with that one there. Undo the nut and you can just pull it off the board. That's the fuel sender. A few little basic ICs on there, nothing too special. Now the speedo is another thing. But again, it's got a big wiper, or a big rotor arm. I'm guessing the more rapid the pulses are, the more it tries to force that magnet around, because you can see it's spring loaded, so it wants to return home to 0. But the stronger the pulses, or the faster the pulses, the more that magnet energizes and the more it winds it around. I'll see if I can get that apart up close. The rest of this, well, I'll take the PCB off. There's a giant ceramic capacitor on there, and a diode, probably a protection diode or something on there. And I'll get the PCB off, and that's about it. The rest of that stuff's all junk. So let's have a look at this odometer and speedometer cluster assembly. Yeah, interesting. I wonder if that converts pulses into a almost a synchronous signal to drive this counter. Wouldn't surprise me. That's definitely a driver IC by the looks of it. It's got a big center heatsink pin on it. So the chip itself, the die itself, is actually heat sunk through that big center pin that goes from side to side. It's quite characteristic of a motor driver. Okay, well, that's the main PCB for it. Pretty well made, nice big thick heavy traces. It's not half bad at all. They're tinned as well. Again, solder work on the main connector's either been redone or it's just exceptionally good off the bat. The instrument cluster doesn't have any stickers or any signs of being rebuilt at any stage. Looks like they just do it by default. This is probably all hand assembled. I'd say that it's all production line stuff and someone goes along and solders all this by hand, which is why they're so good. Yeah, given the very light coating on here, they wouldn't put it through a solder bath, no way. You'd end up with too much build up on these pads and you wouldn't get your bulb holders in. Yeah, typical 90s stuff, 1993, 1994. Mask on the silk screen there. It's actually some pretty good equipment, it's well made. Even the plastic substrate, the white plastic housing that everything sits in is incredibly solid. I've dismantled a few car instrument panels before. I think the last one I actually videoed was from a Chrysler / Plymouth Voyager, and it was all a mixture of digital gauges and vacuum fluorescent displays, and it was quite flimsy. But this old bit of Australian made automotive history is, well, history. There's still a dime a dozen at the moment, so if you are interested in one, go to your local wreckers and they'll probably just give it to you. There are a lot of Falcons and Fairmonts of that era around, and most of them have gauge clusters with busted odometers, and yeah, they're cheap as chips. I mean, my scrapyard just crushes cars complete now. They don't bother parting anything out. Well, they never really have, and that's where I got this from. I just pulled it out of a scrap Falcon that they had at the yard. And yeah, I paid like $5 for an entire carload of stuff. Yeah, so we'll have a look at the speedo cluster. There's only a couple of Phillips, and that's about it. I've got to take that side off, take the drive motor off. That's all riveted in, so that's going to be tricky. I'm going to have to drill all of that out. But you can clearly see the rotor arm there. It's all pulse driven, obviously. See, there's the typical problem. Very typical problem, those teeth have sheared off. When you buy the gear kit, that's basically all it comes with. Although, I think mine had two. It was a little more complicated than this. I'm pretty sure mine had two, unless it's in the back here behind this one. It might have just been one. I might have had that one, yeah. I remember that, you got to press that on. It's quite tight. Yeah, so you get that one and that one in the kit, but that's usually the one that strips. It's very stuck. It was quite hard for me to just free that up. It's obviously stuck hard on its old lubrication. Hit it with some very fine silicon grease or something like that. But that is how those odometers go out. There's the permanent magnet rotor. It's got 1, 2, 3 poles, so it's like a 3-phase kind of thing. 3-phase motor. And that should be pulse for the speedometer. Yeah, power signal. How do I get the rest of you out? Probably violently. I'm hoping there's a way to just split this case, but it doesn't look like it. There's all these little retainers pressed in, and these drums are all permanently fixed. They don't make it easy. Just walk that pin out. Not something you should do to a car that you intend on reselling. You can play with your own odometer, but tampering with one on a vehicle that you intend to sell is actually a crime. It's called odometer rollback, and basically vehicle fraud or whatever you want to call it. That one there only goes in one way. There's a blind hole in the back. That one might be able to get out. No. Oh, it's got a retainer in there. There's a little brass. I need a little pin wrench to go in there and wind it out. I might find a more brutal way of getting this apart. I just want to get the speedometer off the back. I'm just going to drill those rivets out. Bugger it. That's all that's holding it in there is these little brass rivets. Okay, well, one thing I should have realised is the whole thing just snaps in just like the rest of it. It's quite alive and happy. It's a voice coil assembly. It's just like a hard disk drive head assembly. And if I give it 1.5 volts, just using a AA battery, it works. It doesn't peg it, like it's only receiving probably 3/4 of its signal voltage, because that's pegged hard, and that's all the way down to zero. Well, zero is probably past that point when the needle's hitting the vise. Actually, no, that is zero down there. So that's zero, that's pegged. So it's just a little bit past half its rated voltage. It's probably rated for about 3.2 volts pegged, and right now it's probably sitting about 160 kilometers an hour or something on the faceplate. It's pretty cool. Just a little voice coil, little baby one. There's probably very little magnetism in that steel loop there. It's not even a rare earth magnet or anything. It's just a, unless there's one on the back of it. I don't think so. There could be a magnet on the back of it, but I can't see anything up close. It just looks like a steel coil, a steel loop, like a just past horseshoe shape. Yeah, neat little bit of kit. Still works well. Might find a way to stick that on the computer and have that as my little hard disk drive activity meter. I'll obviously need a better driver than the LED signal, but I've got a few different pulse-based drivers here. Might be able to make something out of them. Anyway, given how long this video's gone, I think we'll do the analog speedometer in another video. Thanks for watching.